So let's deal with the elephant in the room first. So today we're going to do de Moivre. There we go. So today we're going to do a little de Moivre action. We're going to find some roots. There is going to be a test on complex numbers this week, Thursday. It'll be one of those in-class type things, but I think you'll be able to get it done in class. If not, we'll figure it out. But so that'll be this week, Thursday. And then also this week, Thursday, in-person people, you'll get a copy of, and then we actually might tomorrow too, I don't know. One of these next 2 days, you'll get a copy of the NTC review for the final. Okay? So that final is going to be Wednesday and Thursday of next week. Okay? And we need to do it that way because we have to correct them and we have to get them scores entered and all that stuff to determine if you are going to have us put your grade in to NTC, or if you're going to just say, no, I don't want my grade to go to NTC. And we need to do that the following week. Okay? Especially for the seniors in the room. So we'll have that. Okay? So that's why your final is actually a little earlier than what we would normally want, but we have to do it that way just because. Okay? Also, in-personers, textbooks, if you bring them, throw them on the cart. At Homer's, if you wanted to drop off your textbook, there is a pile started downstairs just inside the main door. If you go just past the attendance window, that's where the math table is, and there's a big stack of, there's like 6 or 7 pre-cal books on there too. Likewise, in-personers, if you wanted to put it down there because you forgot it today or you forgot it, you never remember to bring it to class, and when you walk past there all the time, that's fine too. If not, they can just go on the cart and we'll deal with them. Okay? Love it. So, we talked about de Moivre's theorem last week with multiplying and dividing complex numbers and taking powers of complex numbers. So, here is 1 plus I times the square root of 3, and we're taking it to the 4th power. Now, we could take 1 plus I squared to 3 times 1 plus I squared to 3 times 1 plus I squared to all that fun stuff. Or we could just simply use de Moivre's theorem. The downfall with using de Moivre's theorem is that we need to convert our standard form, okay, that's a standard form complex number, we need to convert it into trig form. So we need to do 2 things in order to do that. First off, the chair's got to go. Okay? Second off, we have to figure out what our R value is. So we're going to take 1 squared plus the square root of 3 squared, and we're going to take the square root of that. Okay? 1 squared is 1, square root of 3 squared is 3, 1 plus 3 is 4, so this is the square root of 4, which is just 2. Then we also need to find the reference angle that we're dealing with, or the actual angle of theta. Since this is positive, positive, that means that this complex number is in quadrant number 1. So my reference angle is my actual angle. So theta here is going to be the inverse tangent of the square root of 3 over 1. Well, square root of 3, okay, inverse tangent, that's either going to be 30 or 60. Which one? Or 60? Which one? Inverse tangent of the square root of 3. It's 60. Okay? And it is 60 degrees. Okay? So this, written out here now in trig form, is really 2 times the cosine of 60 degrees plus I times the sine of 60 degrees to the fourth power. So that's going to be 2 to the fourth power times the cosine of 60 times 4 plus I times the sine of 60 times. Two to the fourth, 16. Sixty times 4. That would be the trig form of our answer, right? What is the cosine at 240 degrees? What do we got? Cosine at 240, what do you got? What do you got? Negative 0.5? Okay, yep, negative 1/2. So this one here is negative 1/2. What is the sine at 240 degrees? You got A-dubs? Yeah. Sine at 240? Negative square root 3 over 2. So this could also be 16 times negative 1/2 is negative 8, right? We shouldn't put plus there because it's negative. 16 times negative square root 3 over 2 is negative 8 square root 3. Oops, correction. It's just negative 8 square root 3. I don't know why I was putting it over 2 yet. So it'll be minus 8I times the square root of 2. Yes? Good times. What about the negative on the square root of 3? I put it right here as the minus 8. Yep. Oh, okay. I understand. I feel your pain. Good times. So, can we use de Moivre if we're taking the root of a number? Well, let's take a step back and let's talk about what it is to be the nth root. Okay? So for any real numbers a and b, if a to the nth power equals b, then a is the nth root of b. Okay? So basically it's just saying like if 2 cubed is 8, 2 is the cube root of 8, is what it's saying. Okay? If 9 has, that's a cube 2 again. So 9, that would be the 6. If 3 to the 6th is 729, then 3 is the 6th root of 729, is what that's saying. Okay? But what it also is saying is this part right in here. And this part is actually kind of important. Is we can take the nth root and we can write that as an exponent. Okay? So if we're taking the fourth root, that's really taking a number to the 1/4 power. Okay? We're thinking back to a couple of different sections that you've had over the years. Okay? Your exponent rule. So if we're taking an nth root, that's really 1 over that root to the power. Now that helps us because now we have the root as a power, and we can utilize that power into the mod. Okay? That formula that we were just using. Okay? So we got that. So now let's think about this in the context of solving an equation. Okay? So on the bottom of that sheet that you've got, or that page that you're looking at right now, there's 4 different equations. Okay? And we can solve them rather quickly. So this first equation, how many solutions are we going to have in number 1? How many answers do we get? 1, right? Okay. And so we would get that answer by saying, well, first off, we'd subtract 3 from both sides. And then that would become 2x equals -3. And then we would divide by 2 on both sides, and we'd get our answer of x equals -3/2. And that would be the only answer that we would get there, right? Okay. Fast forward to number 2. How many answers am I going to get in number 2? 2, right? Okay? Because we can take we can square root both sides. And when we square root, we got to add in the plus and the minus. So that's going to give us x equals plus or minus 4 there. And I got 2 answers, +4 and -4. Okay. Love it so far. Equation number 3. How many answers do we get? Or how many answers should we get? 2, right? Okay. Is it factorable? No. So when it's not factorable, then we got to use our old friend, opposite of b plus or minus the square root b squared minus 4ac all over 2a. And so that's going to give us -2 plus minus the square root of 4 minus 4 times 1 times 5 all over 2. 4 times 1 times 5 is 20. 4 minus 20 is -16. Square root of -16 is -4i. Or excuse me, it's just 4i. And so then we get x here is -1 plus or minus 2i. And again, we get 2 answers. -1 plus 2i is an answer. -1 minus 2i is an answer. Okay. Seeing the pattern? Yeah. However, whatever the degree is, that's, how many answers we should be getting. Okay. So in this last one, how many answers should we get? we should get 3 answers. And first, we start by factoring out an x. And this one is nice enough where now my trinomial is factorable. So then this would become 2 numbers that multiply together to be positive 2 and add to be negative 3 are negative 2 and negative 1. Then what do I do? How? Each factor equals 0? And we get our 3 answers, 0, 1, and 2. Okay. Love it. Good time. Let's take it up another notch here now. Now let's say x cubed plus 8 equals 0. So normally what you would want to do is you would want to subtract 8 from both sides, right? And that would give you x cubed equals negative 8. And then what do you want to do? Cube root both sides, and typically that's what we would do. We would cube root both sides. And what's the cube root of negative 8? Negative 2, right? And you're saying, I'm done. But what's the problem? There's what? There's supposed to be 3 answers, and how many did we find? 1. And if I know anything about anything, it's that a cubic function does the disco. Right? Okay? It goes in opposite directions on opposite sides. So this function actually kind of looks like that. So I know that negative 2 is not a triple root. Okay? Because it's not one of those kisses and comes back down. With me? Okay? So we've got to find the other ones. Okay? So I'm actually going to pick it up here at this step. At x cubed equals negative 8. And when we take the cube root on the left side, that's the same as taking the 1/3 power on both sides. A cube root is the same as taking it to the power of 1/3. Well, now we've got powers, right? So now we can use de Moivre. Let's change negative 8 into a standard form complex number. Well, that would be, so then this would be x equals something to the 1/3 power. And that something is going to be negative 8 plus 0i. Now it's a complex number. But to use de Moivre, we've got to have it in trig form. Right? Okay. So that's going to be x is equal to, what's the radius? What's the r value for this complex number. What do we got? 2? I don't like 2. 8 squared plus 0 squared, square root of. Just 8. What's the direction of this one? Inverse tangent of inverse tangent of 0 divided by 8, right? It's just 0? Do I like 0? Because if I graph this one on the real and imaginary plane, right? -8, comma 0i is over there. So what's my angle? 180. Okay, my angle is actually 180 degrees. Oops, I gotta move this over now. Okay. So now we can apply de Moivre, right? Right? Okay. So now let's apply de Moivre. So de Moivre would say, we'll go in purple here, 8 to the 1/3 power times the cosine of 180 times 1/3 8 to the 1/3 power is 2. (180 times 1/3) 60. Right? Okay. So let's put that one as our first answer. Now, if I were to graph that again in the complex plane, that would be right there. And this angle right there would be 60 degrees, and my R value here would be 2. Agree? We've got that -2 one already, right? Because we found that one when we took just the regular old cube root, the real one. Well, that is going to be 2 times the cosine of 180 degrees plus I times the sine of 180 degrees. And that one, I'll do in red, is out there. So we've got 2 of them. this gap right here is how many degrees? How many? It's 120, right? Because we went to 60 and then we went to 180. So if I went another 120 degrees, run out of color. I would have the third. Well, what angle is that going to be at? $300, right? Because we added 120 to 180. And that is it. And those 3 points are the, so that one, red, and this one was, and those 3 points. Now, do we see a pattern in our 3 trait points, our 3 answers? See a pattern? What do you got? They're all 120 degrees apart, right? How can we get 120 degrees if I need the cube root on a circle? 360 divided by 3. Yeah. Okay. And that's going to tell me that gap between my roots. So if we were taking the 5th root, what would the gap be between roots? I shouldn't say gap. What would the angle measurement be between the 3 or between the 5 roots? 72, right? Okay. Because 360 divided by 5 is 72. Okay. Love it. Okay. Love it. So let's get a plan and let's simplify it a little bit more. Okay. So first off, we would say that this is, instead of being x cubed equals 27, we would think of this as x equals 27 to the 1/3 power, right? Which is also that, correct? Which is also that. With me on all of those. Okay? So first, the plan is you apply de Moivre to get the first root. Right? Okay? So we're going to take 27 here to the 1/3 power. We're going to take our angle and multiply it by 1/3. So our simplified plan. M-O, go all the way back. I didn't have it. What is DeMauve? M-O-U-V-E? M-O-I-V-R-E? DeMouvre? Okay, so we're going to apply DeMouvre. DeMauve. 27 to the 1/3 power? 3? 1/3 times 0? Okay, so that's going to be my first one. Second thing we're going to do is we're going to figure out 360 degrees divided by what's called the index. Remember that this number here is the index. Okay? Or it's your original degree. Okay? It's the number that we would put in the radical. Okay? And that is going to be the angle gap. So in this case, what's my index? 3. What's 360 divided by 3? 120. So to find my next 2, I simply, my radius is going to stay the same. I take 0 plus 120. That gets me my, oops, I put 1. Come on, that's very better than that. That's my second one. And then my next one, I get that, right? So over here, this would have been 360 divided by 3 is 120 degrees. So here I add 120 degrees. Here I add 120 degrees. What happens if I add 120 degrees again? I'm back to 0 again. Right? And I found my 3. All the way through. Yeah, buddy? Love it. Okay? So, and really, that's it. That's our plan. And that's the simplified version. You first apply DeMauve on the first root to find the very first one. And then you just take the index, divide it into 360, and that's your angle gap. Boom, 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 done. Okay? All right? Let's try it, or I should say, you try it now on finding me the 5th root of that number. Okay? So first we're going to have to apply DeMauve, which means in this case we're going to have to convert it into trig form. Then we're going to apply DeMauve, and then we're going to figure out our gap. Go for it. $32. Okay, 32? Yeah, 32. It's 3069. 32. That. So this is really 32. My first root is going to be 32 to the 1/5 power times cosine of 120 times 1/5 plus I sine of 120 times 1/5. 32 to the 1/5 power. Fifth root of 32. 2. 120 times 1/5. 12? 24, right? Yeah, 24. So there's my first root. Okay? Then I go off to the side here and I say, well, 360 divided by 5 is 72. So my next one is 2 cosine of, what would that be, 96? My next one, 96 plus 72, 168. My next one, 168 plus 72, 240. And my last one, because I got to get 5, is what, 312? And that's my 5 answers. Questions, comments, concerns, clarifications? Love it. Good test. Try that one. Cosine of negative, so that would be what, 240 degrees? Yes? Yeah. So my first one is going to be 12 to the 1/4 power times cosine of 240 times 1/4. So that, this one, I would just leave it as 12 to the 1/4 power, or the 4th root of 12. Okay? Because that's just your R value, and it's just going to stay the same the entire time. Okay? But then it's going to be 60 degrees. Agree? So then my second one is going to have the same R value, except it's going to be 360 divided by 4 is going to be 90 degrees away. So that's going to be 150 degrees. My third one is going to be 90 degrees away. That's 240 degrees. And my last one, oops, I almost put 3 there, is going to be 90 degrees away. Okay. CIS is cosine plus I sine. And there's my answer. Good time. Yep. Agree? Trig form. We shouldn't even need to do any figuring on this one, right? Trig form of this complex number. What's our R value? 16. The only number we have. Theta value, or degree value, I should say. 0 plus 16i. What? Not undefined. It's got to be somewhere between 0 and 360. Right, but we don't even need it. That's why we can't use the calculator on this one. Where on the real complex plane is 16i? Straight up, right? Right? So what's my angle? 90 degrees. You got it or not?
What?
You got it? Oh, because it sounded like you said, how did they get that? Oh, okay. Oh, that was a good one. Okay. So, first one. (16 to the 1/4 power). 2. 90 times 1/4. 22.5. Is that legal? Why, Lexi? Just agree, right? As long as it's in between 0 and 360, it's legal. Yeah? Right? If we ever had to take the 7th root, they'd get ugly real fast. Okay? Just because of the decimals of 1/7. Okay? So there's my first one. What's the gap? The angle gap betwixt all of ours. 90, right? Yeah. So it's 90. So my next one would be at, what's that? 112.5. My next one would be at 202.5. And my last one would be at 292. Good times. One last one. And the only reason why I want to do this last one is because it just got a little different wording, I think. I don't think we've had, did we have one like this? Where it said find the, oops, we did have a find the 5th root. That's right, find the 3rd roots of that one. Go for it. One last one. Exactly. Both the same. That means my reference angle is 45 degrees. Negative, positive is quadrant number 2. So that's going to be 135. So my first one, two times the square root of 2 is going to be taken to the 1/3 power. Now, if you would write this as the 6th root of 8, I'd be okay with that. We can also just write it as 2 square root of 2 to the 1/3 power. Just put it in instead of right? And 135 times 1/3 is 45. Then we take 360 and divide it by 3. That gives us 120. So we've got gaps of 120. Yes? Good times. The last couple of pages in your purple packet are the review assignment for 6.6. We'll do some more of this tomorrow, along with some review stuff. So if you wanted to start your review, and I get it if you want to just take these last 7-8 minutes off, I'm totally fine with that. But so we'll do some more of this tomorrow, along with some review, and then your test is on Thursday. Okay? Thanks for playing along.